Hey students, I'm Mrs. Klee, one of the chemistry instructors here at Florida Virtual School. If you're having any difficulty gathering the materials for the 8.03 Solutions Lab, then this video is for you. We will go through the pre-lab and the data collection and the majority of the parts of the lab together. As we go through the video, you'll fill out your lab template. After we analyze the data together, you should be ready to do those conclusion questions on your own. So you'll fill those out and then you'll upload the document as normal. And then you're done. So let's get started.
Let's work through the pre-lab questions first. So what is a solution and what is meant by dilution? A solution is just a certain amount of solvent, which water is often considered to be the universal solvent, but it's not the only solvent, with a certain amount of solute dissolved in it, meaning something like concentrated orange juice dissolved in water. Now, when we dilute it, all we're doing is adding water. So we're just watering it down. The actual amount of the solute doesn't change. As in here, as you can see, purple dots don't increase. We've just increased the water. So when we increase the amount of water, something called the molarity decreases. Now, molarity is just a word that we use in chemistry, which just means concentration. How concentrated is your solution? Well, if we add more water, it's going to be less concentrated, and so the molarity is going to decrease. And we have this formula that helps us to figure it out. Moles of solute divided by liters of solution. So let's go ahead and start with some of these questions here. In order to do this lab, we're going to mix up two different molarities of some sort of powder drink mix. We're going to mix up a 0.5 molarity and a 1.0 molarity. The higher the number, the more concentrated it is. So in order to do that, the first thing that we have to do is we have to figure out the moles of our solute. So in this case, our powdered fruit drink mix. And I've noticed there's a typo here. Sorry about that. Made from sucrose. What is sucrose? Just plain old sugar. Okay, so we're going to figure out the molar mass of the sugar first and foremost. We need the periodic table, so I've just cut out a couple of little blocks from the table for carbon, hydrogen, and oxygen. So we have to figure out what elements we have in the compound, which we have C, H, and O. We have to figure out the molar mass of each of those elements, which we get from the periodic table. And then we have to figure out how many atoms of each element we have and multiply the molar mass of that element by that amount. So you look up into the compound and you see that we have this amount of each. Okay, so we're going to multiply that out. And then after we get all of this done, we're just going to total it all up for our molar mass of sucrose, which again is just sugar. All right, so I'm getting approximately 342.177 grams per mole. That's our unit because this is how many grams of sucrose is going to be in 1 mole of sucrose. So we're going to need that information to do the next question. Scroll this on down here. So it says using Stoich, determine the mass of the powdered drink mix needed to make a 1 molar solution of 100 milliliters. Now we don't want to have a ton of it. We don't want more than we need. So we just want 100 milliliters. So we can adjust the formula. So we're going to go ahead and use the formula, and usually molarity is just abbreviated with a capital M, and then moles is lowercase m-o-l. I know it's very similar. And then we always have to convert our volume of our solvent into liters. So let's see that we have it in milliliters. So in order to convert that into liters, we're just going to need to move the decimal over 3 places, or if you want, you can divide by 1,000. Okay, so let's figure out, first of all, the moles. So we're going to rearrange our equation. Moles equals molarity times liters. And now we're going to fill in what we know, 1.0 molarity and 0.100 liters. All right, so doing the quick math, this is going to give us 0.1 mole. So what are we going to do with that? Well, we're going to use that information to figure out the mass of the powder drink mix that we're going to need to add to this certain amount of water in order to get the concentration that we need. Okay, so we know that when we're converting from moles to grams, what we're going to do is we're going to take the moles, and this is of the sucrose, by the way, and I'm just going to abbreviate CHO rather than putting in all of the amounts of each atom. And 1 mole of this particular sucrose, CHO, is equal to 342.177 grams, which we calculated above. So this is where we get our grams per mole. And then when we complete this, we're going to get 34.21, approximately 0.218. Now this is just grams because our moles are going to cancel out now. So this number here, 34.218 grams, is not the molar mass. It is the mass of the powder drink mix that we need to add to a certain amount of water in order to get the 1.0 molar concentration that we need. All right, so we are going to need that for when we actually do the lab. So we'll come back to this. All right, and the final question here is what mass of powder drink mix is needed to make a 0.5 molar solution of 100 ml? Well, if we just made a 1.0 molar solution, 0.5 is just half of that. So all we actually need to do is take half of this amount and put it into the same amount of water. Okay, so we're just going to divide this number by 2, and that's going to give us our answer. So 34 34.218 grams divided by 2, or roughly 17.109 grams. And this is of the powder drink mix, whatever we decide to use. All right, so next we're going to move on to the actual lab. Okay, go ahead and open up the lab template and give your lab report a title and state the objective of our investigation. Why are we doing what we're doing? Choose a hypothesis, one that will predict the solubility factor that you choose and how it will affect the solution. For example, you could choose this one, heating up a solvent increases the sweet taste of a powder drink mix, or you could think heating up the solvent decreases the sweet taste. You could choose any of the other solubility factors, as long as you choose one. You're going to list your independent, dependent, and controlled variables. Now, these variables are going to be related to your hypothesis. So what will you be changing in each trial? What will you be measuring in each trial? And what always stays the same? Make sure you include your materials in the report and the procedures. So I'm setting all of this up for you. I have the cups labeled already with the 1.0 molarity and the different solubility factors, and the 0.5 molarity with the different solubility factors. I will also mix the tea mix according to the package for the control. From our pre-lab, we determined that in order to mix up 100 milliliters of a 1.0 molarity solution, we would need to add 34 grams of the drink mix. and fill to 100 milliliters with water. Because I don't have a kitchen scale, 1 tablespoon is going to equal 12.5 grams and 1 teaspoon will equal 4 grams. So for the 100 ml of the 0.5 molar solution, it's going to be roughly half at 16 grams. We will test all 3 solubility factors for each molarity. We will not be testing the control solution, we just taste it and compare it with our 1.0 and 0.5 molarity. Our 3 solubility tests will be temperature. How does temperature affect solubility? We end up mixing a teaspoon of sugar into each room temperature tea and then a teaspoon of sugar into the heated tea. Agitation or stirring, how will that affect solubility and the taste? And finally, particle size. We will be using sugar cubes, which you've probably never seen, and just regular granulated sugar to see how that affects solubility. All right, let's get going.
So I think we have everything just about set up for our lab. I'm going to zoom in on a few things that we have here. So first of all, we're going to mix up the control, which is going to be exactly the way the drink mix package tells us that we need to mix it up. So right there on the drink mix package, it tells us that we're going to put about 2 1/4 teaspoons to 100 ml of water of the powder, and that's going to be about 9 grams. Then we're going to mix up a 1 molar solution. And now you notice that's a lot more powder, and we're going to end up with about 34 grams based on our calculations from the pre-lab, once again in 100 milliliters of water. And then the 0.5 molars is half of that, and that's going to be approximately 17 grams, so I measured that out, and we add that to 100 ml of water. I then poured 100 ml of each into the different solubility tests. So we have 1 molar with heat and without heat, 1 molar without stir and with stir, 1 molar with sugar and with sugar cubes, and the same but with the 0.5 molar solution. So the first test, solubility test that we're going to do is we're going to take a teaspoon of sugar, it's a teaspoon, and we're going to put a teaspoon in each of the 100 ml, and this is the 1.0 molar concentration. So I'm not going to stir it because that's not part of our solubility test, but what I'm going to do is I'm going to leave this one alone and taste it without the heat, and then I'm going to heat this one up and taste it. All right, so the next thing, we're going to go ahead and put a teaspoon of sugar in the without stir and a teaspoon of sugar in the with stir. All right, so I'm going to have to stir the with stir. Stirring, stirring, stirring. Now I get to taste it. I can't say I'm looking forward to this, but for you guys, I will do it. All right, so this is the 1.0 molar with stir. I'm going to taste it. And that's sweet. Really sweet. Now this is a 1 molar without stir. It's really not as sweet, even though I put the same amount of sugar in both. All right, next is the 1.0 molar with sugar and the 1.0 molar with sugar cubes. So this would be particle size. Okay, this one was agitation, and this one would be particle size. All right, so here we go again. Teaspoon of sugar, and then a sugar cube. 1 cube is approximately a teaspoon. Okay, but I am not supposed to stir this. That's the thing, okay? You can't do 2 different solubility tests. So I'm going to go ahead and taste it. This is with the sugar. It's okay. It's a little sweet, but it's not too bad.
And then this was with the sugar cube in it. It's not good, but it's definitely less sweet. Okay, so that concludes the 1.0 molar test, and we're going to do the same with the 0.5. Okay, so now it's time to do the 0.5 molar, which, if you remember, is half the concentration. We have the same solubility test with stir, without stir, and I already put the sugar in there just to save some time, but I'm going to go ahead and stir that. Taste them both real quick. Tastes more like tea instead of just sugar water. Tastes kind of bitter. Okay, the heat we'll do last because I need to heat those up. This is the 0.5 with sugar, not stirred. Kind of bitter. And then this one with the sugar cubes. Yeah, at this point it's kind of hard to tell, but I can summarize all of this in a data table, which will be on one of the next slides. Let me go ahead and heat up the solubility test with and without heat. We'll test that, and then we'll summarize. All right, so this is our last test. These are with the heat. So I've got the 1 molar with and without heat and the 5 molar with and without heat. So I'm gonna try the without heat first. And now the with heat. Tastes really different with the heat. I don't like it. It's very sweet and kind of weird tasting. All right, without the heat. And with the heat. And this is the half concentration. I guess some people might really like this if they like super sweet drinks. Me, I don't feel so good now, but I did it for you guys. So now we're gonna go ahead and analyze this data, put it all together. Okay, I'm back and I'm feeling better. So let's go through the data collection. This is the information for the control, which I did not try on camera, but it tasted just like iced tea should. And this is the data collection from our lab. In general, we found that the 0.1 molarity was always sweeter than the 0.5, which makes sense since it is twice as concentrated. And when we applied heat, when we stirred, and when we reduced the particle size by using granulated instead of sugar cubes, we also found that it was sweeter. So we were able to increase the solubility with those factors. You will need to fill out the analysis and conclusion questions in order to get full credit. Your first question is just writing a summary paragraph and deciding whether or not our hypothesis supported the data. This is just an opinionated question. Which molarity would you recommend, and what directions for mixing would you create for the drink package if you had to? And for this heated solute, if we cooled it down, would it taste the same? If we were going to make another molarity, in this case 0.2 molarity, and we were going to make that from our 1.0, so in other words, we're going to dilute it, how would you do it? Well, hint, hint, you're going to use this dilution formula, recognizing that C represents the concentrate and D represents your diluted formula. So what is your concentrated molarity? Well, 1.0. And what volume of 1.0 molarity will you need in order to get 100 milliliters of a 0.2 molarity fruit drink mix? This says to make this particular concentrate, but we're not going to actually have to do this. But what I want you to do is think about it and answer the question. If we did dilute the 1.0 to 0.2, how would the tastes compare? And how would it compare to the control solution? Keeping in mind that the 0.2 molarity is less concentrated than the 1.0. And finally, we have a little bit of a calculation here where we have a scenario where we're saying that baking soda, this compound here, can be added to a fruit drink mix, which this is it right here, which is really just sugar, to create some sort of carbonated drink. And you've got CO2 right here, which is what would give you the fizz. What we want to know is how much, what would be the proportions of baking soda to drink mix in order to get a good tasting drink. So the first step to this is going to be to figure out the molar mass of the citric acid and the baking soda. Use the pre-lab video for help calculating molar mass if you need it. Here's the actual question then. How many milliliters of a 0.8 molarity solution of the citric acid, which is again just the sugar, would be needed to react with 15 grams of baking soda to get the best tasting drink? So what I've done is I've set up the stoichiometry for you. I don't have everything filled in, but this is the general pattern that you will follow. Wherever you see a question mark, this is what you have to decide to fill in. All right, once you've got everything filled in, you can upload to the 8.03 solutions. Kick back, enjoy the rest of the day because you are done. I appreciate you coming. Bye-bye now.